Hi, welcome to the fifth analytical geometry tutorial titled Getting Around the Circle. In today's tutorial, we are going to be looking at the circle in context of analytical geometry. In terms of what you need to know, you need to be familiar with your grade 10 work, you need to have gone through the first 4 analytical geometry tutorials, and I'd also recommend you go through the section in algebra titled Completing the Square. We will begin by looking at how the equation of a circle comes about. Firstly, I'm going to say that the equation of a circle has really got nothing to do with the circle itself. It's actually the equation of the radius. Now let's look at what I mean by that. If I am drawing a line from my 0 point, 0, 0, my origin, and I'm drawing it to the point x is equal to 4, y is equal to 3, let us look at what the distance of that line would be. Let's call that line r. r is going to equal, all we're going to use is our distance formula. Remember, that's the origin, so it's 0, 0. r is going to equal x2 minus x1, 4 minus 0 squared, plus y2 minus y1 squared, and the square root thereof. To get rid of the square root, we're going to square both sides. That means that r squared in this case is equal to 4 minus 0 squared plus 3 minus 0 squared. But instead of 4, now let's imagine this. Let's take this point. This is the center, this is the point, and let's rotate it circularly a certain amount of degrees to be that point over there. Would r still not be the same distance? Except we've got a new x and y value. And if we rotate it some more, we're going to again come to a new x and y value. And if we carry on rotating it around the origin or around the center of this, what's supposed to be a circle, we're going to continuously get different x and y values, but all of those x and y values, or all pairs of those x and y values, using the distance formula, should give you the same r distance. So instead of saying 4 minus 0, I'm going to say x minus x2 minus x1 squared plus y2 minus y1 squared. But notice something, that at no point in time does the center change. It's always the coordinates 0 and 0. That means that r squared is going to equal x2 minus 0, which is just x2 squared, plus y squared. And this is the standard equation for a circle centered at the origin. Let's just write that in. That's at origin. Centered at origin. In order to get the r squared, all I need to do is substitute in to x and y any point that I have. In this case, I've got the 4 and the 3, which means that r squared is going to equal 4 squared plus 3 squared, which is equal to 16, plus 9, which is equal to 25, and that is what r squared is going to equal. That means that this equation for this example will read x squared plus y squared is equal to r squared, which is 25. Remember, our radius is not 25. Radius squared is equal to 25. That means that radius is equal to 5. But the standard form of the equation is r squared is equal to y squared, x squared plus y squared. Now that's for a circle that is centered around the origin. We are now going to look at the equation of a circle that is not centered around the origin, that is centered around another point. Let's draw in a Cartesian plane, or an axis of x-axis, y-axis, and let's put in the point x is equal to, let's say, 3, y is equal to 4. This is going to be our new center, and let's sketch a circle that looks more or less like a circle. No, it doesn't. It's close enough. And I'm going to put another point over here. This point is going to be x is equal to -1 and y is equal to positive, let's go with positive 3. So it's actually sort of slanting downward. Anyways, we are now going to look at the equation of the circle. Again, we are not going to look at the equation of the circle, but rather we are going to look at r. Now, r squared, in this case, using the distance formula, y2 minus y1, or rather let's start with x2 minus x1, minus 1 minus 3 squared, plus y2 minus y1, which is 3 minus 4 squared. Alright? If I work out r, I'm not going to work out r squared just yet. Instead of saying minus 1, couldn't there be a number of different x and y values or x and y coordinates along the edge of the circle that could make that true? So instead of saying minus 1, I'm going to say x, or rather x2 minus x1 squared plus y2 minus y1 squared. Now this x and this y, as I've said, can have any coordinates. That means that r squared is going to equal any x2, or let's just call that x, minus, if I'm rotating my radius, am I changing my center of the circle? No, I'm not. My center of the circle is still staying 3 and 4. But x and y are going to change continuously. That means that r squared is going to equal x minus 3 squared plus y minus 4 squared. And that x and y can be any values around the circle. That means that r squared is going to equal, now instead of saying x minus 3, isn't 3 and 4 the center of my circle? X minus p squared plus y minus q squared, where p and q are simply the center of my circle. That means that the equation of a circle not centered around the origin is going to read r squared is equal to x minus p squared plus y minus q squared. Problem with this though is, well, this is the standard equation. In relation to this example, my r squared